In this video we're going to take a look at container packing past paper questions, only a couple from the ones that are available on the National 5 Maths Applications website, simply because similar to standard deviation, they do get a bit repetitive. Okay, so once you master really the technique, doing a good couple, you should just follow the same process for each type of container packing question, no matter what the context really. But just make sure you obviously read the question carefully in case it does ask you anything different. So question number 1, the books are placed in, are to be packed in boxes for transport into the bookshops. The dimensions of the book and the internal dimensions of the box are shown in the diagram. So we've got the book there, and we've got the box. Hopefully something you kind of notice straight away, we're kind of mixing up our units. We've got millimetres, we've got centimetres, and we've got metres. That's something that's going to need to get fixed. The books need to be laid with the front cover facing upwards in the box. They must all be aligned in the same direction. Calculate the maximum number of books that can be packed into each box. So that bit there about saying that it has to be facing upwards, that's kind of like a restriction that's placed, and that actually helps because that limits the number of possibilities that there is. Alright, now first things first, when we're kind of then comparing, to do a container packing question, what you're looking to do is compare the lengths and then work out how many you can fit in. So obviously at the moment I can't really compare these because they're not the same units. So what we're going to do is I'm going to make the millimetres into centimetres. I'll change that very quickly into 100 centimetres. And I'll do the same for the millimetres. So that's going to be 2 centimetres. That would be 12.5 centimetres. Just dividing by 10, folks. That would be 19.5 centimetres. So those are the lengths I'm now going to use. And then I'm going to start out by filling in my wee tables. Alright, good to set out a table for our container packing type questions. The way I like to do it is I will have the corresponding length of the container itself, the length of the box or whatever, in this case it would be the book, and then the number. So that's just the number that I'm going to be able to fit in along that dimension. So the way that the book's shown is a way that I could pack that. I could have 100 packed into the box like this. Alright, so that's the first one we're going to do. So what I'm going to write down is the measurements for the container. So it's 20 centimetres, 100 centimetres, and then 50 centimetres. And now what I'm going to do is then write the corresponding values for the book. So if we think about placing it this way, the 20 millimetres or the 2 centimetres will be corresponding to the 20. The 12, that should be 12.5 centimetres will correspond to the 100 centimetres. And the 19.5 will correspond to the 50. So that was 2 centimetres corresponding to the 20, 12.25 for the 100, 12.5 for the 100, and 19.5 for the 50. And then I'm going to then divide the left hand side by the right each time to work out how many I can fit in. So 20 divided by 2, these are always calculator ones usually. 20 divided by 2 is 10, so I can obviously fit in 10 whole books along that way. 100 divided by 12.5 is 87.5. Now for these ones, that obviously means that I need to round down, because I can't round up because that would then mean that it wouldn't fit. 88 books wouldn't fit. I'm also not going to have half a book, so for these ones you're going to round down to 87 for that one. And then 50 divided by 19.5, that's going to be, it's coming up for me 2.5641 and so on. So that then means all I can fit in is 2. There will be space, but we're told quite clearly in the question they've all got to be aligned in the same direction, so there's no kind of mucking about with trying to squeeze ones in. Alright, then, so basically what that means is there is 10 stacks, okay? There is 87 going across this way, and then there's 2 going across this way. So there's 10 lots of 87 times 2. So we times these numbers together. So 10 times 87 times 2, and that's 1740. Okay. Oh, tell a lie. 100 divided by 12.5 is 8. So I've made a wee mistake there when I've done that. I think I've divided by 1.25. So this is actually just 8, folks. So doing that wee one again. Just notice that there. Double check. 50 divided by 19.5. Yep. Alright, so 100 divided by 12.5 is 8. So it's actually 10 times 8 times 2, which is 160. Sorry for that. Just make sure that you're taking your time with these. That was me doing it a wee bit quickly. Alright, so that's us done it one way. So that's the book basically positioned in the box the way it's shown in the picture. The only other option, if you think about it, for the cover to be facing up the way is to then rotate this left. Alright, imagine that then rotating left round. Now we've got to think about, well, what will correspond to each way, to each length in the container. So set out my table, container, box, and number. The container, it was 20, 100, and 50. Okay, so this time corresponding to the 20, that's just going to be the 2 centimeters again. This time though, I've rotated this book around so that 19.5 centimeters will correspond to the 100, and then the 12.5 will correspond to the 50, because I've just rotated this round. Okay, so now I'm going to work out how many can fit in each dimension, or each kind of direction. So 20 divided by 2, that was 10, that's the exact same as the one before. 100 divided by 19.5 is 5. And then 50 divided by 12.5 is 4. So this time it's 10 times 5 times 4. 10 times 5 is obviously 50 times 4 would be 200, but you do have a calculator. So the max number then is 200 books for this one. So next question. The tins are packed in boxes, so this is obviously part of another question. Each box has dimensions 60 by 40 by 15. It says quite clearly, store this way up, so they have to be facing that way. The boxes must be packed into containers for ship to Canada. The container has the internal dimensions shown. Nice and easy, the units match, centimetres and centimetres. All boxes have to be aligned in the same direction. Calculate the maximum number that will fit. So, straight away, pretty much the way that this picture is shown here, that's the first option for how we can store these. Alright, so set up my table. Container length, length of the box or the thing you're actually packing, and then the number that we're going to get from that. Container length 240, 1 250 and 260. Okay, the way that the box is shown right now, 60 would correspond to the 240. 40 would correspond to the 1250. And the 15 would correspond to the 260. I'm going to divide the left by the right hand side to work out how many can fit. And again, this is paper 2, so these are, as I say, typically calculator. So I could fit 4 in this way. 1250, divide that by 40. I'm getting 31.25, but that's going to round down to 31. That couldn't be, I wouldn't have a quarter of a box, I wouldn't have 0.25, and I also wouldn't be able to round up either. 260 divided by 15, that's 17.333, so that's just going to be 17. So, times them all together, because that basically means 4 going along the way, 31 back, and 17 stacks up the way. So 4 times 31 times 17, 4 times 31 times 17, 2,108 boxes. Okay, and only other way that I can store this is then by kind of rotating this round one turn, if you like. So this time, the 40 is now going to correspond to the 240. Let me just make out the table again very quickly. $240, 250, 260. So the 40 is going to correspond to this. The 60 is now going to, because that's rotated round, is now going to correspond to the 1250. And then the 260 and the 15 will be the exact same because we're not able to change the kind of direction, if you like, this dimension, because we're told we've got to store it this way up. So, do the division. This is going to be 6. 1250 divided by 60. That's going to be 20.8 ... but it's just going to be 20 then. 260 divided by 15, we've worked that one out already, we get 17 for that. Times these together, so 6 times 20 times 17, 2040. So in this case, the max number is 2108 boxes like that. Alright, last question now. This one here. She puts the bags into boxes. The boxes have dimensions shown below. She exports these handbags to the USA. The container has the internal dimensions shown below. Notice this time we've gone from centimetres and metres, so we're going to have to do something about that. All boxes must be aligned in the same direction. Calculate the maximum number of boxes that can fit in one container. Alright, so for this one, again, straight away, kind of the way that this box is, this one doesn't tell us it has to face a certain way. But what it does do, and this is something I like to highlight, it does have two lengths that are the same. It's actually a square here. Alright, this must be a square. So that will help us out a wee bit. Right, that limits the number of options. So the way that this box is kind of positioned here, just now shown in the diagram, that is pretty much one of the first ways we can display this. First of all though, let's get the units matching. So I'm going to make it all into metres. Divide by 100 to get centimetres into metres, so this will be 0.42. This will be 0.42 as well, obviously, and this will be 0.81. Now I'll set up my wee table for the first one, container, box, and then the number that we can fit that way. So the container is 2.59, 2.44, 6.06. Okay, so the 0.42, that'll be the 2.59 and the 2.44, so that's what we're going to put in here. And the 0.81, that's going to correspond to this length here of 6.06. Sorry, that will be 0.81 that corresponds to that. So now I'm going to divide the left by the right to work out how many I could fit in. First one is giving me my calculator 6.166, but that's just going to be 6. I get 5.8 for this one, but it's going to be 5. And I get 7.48 for this one, but that's just going to be 7. So multiply this together. 6 times 5 times 7. And that's giving me 210 boxes. Okay. Next way I could do it, well, I could rotate this box round so that the 81 is now the length that's corresponding to the 2.44. Alright. So, do another one. Container. That's probably the most challenging part about these questions, is trying to visualise you changing the way that the boxes are stacked, trying to visualise that. So the container length, 2.59, 2.44, 6.06. This time, the 2.549, if I've just rotated this round, I've not actually kind of tilted it. or sat it up in its side, therefore the height's still going to be 0.42. This time though, I have turned the box round, so the 81 is going to correspond to the 2.44, so the 0.81, and then we're obviously left with a 0.42. I'm going to divide left by right, 2.59 divided by 0.42. That tells me that I'm going to fit 6 in. That was one already done. 2.44 divided by 0.81. That's 3. And then 6.06 divided by 0.42. That's going to be 14. Multiplying those together. 6 times 3 times 14 is 252 boxes. So already that's obviously more. Let's just try the final one. Container box number. The container. I'll go back to the picture in a minute. I'll just fill in this table. 2.59, 2.44, 6.06. Okay, so now what I'm going to do is I'm going to take this, and if you can picture it, I'm then going to tilt it up. So this side here is now on the bottom. The height will then be 0.81 this time. So this is now standing up the way. So 0.81 will correspond to the 2.59. Okay, and then the only two measurements we've actually got left is the 0.42. But just to kind of show you, so that's been then lifted up. So 0.42 will correspond to the 2.44 and also the 6.06. I'm going to divide left by right to work out how many can fit in. 2.59 divided by 0.81. That's 3. 2.44 divided by 0.42 is 5. And then 6.06 divided by 0.42 is 14. Times these together, 3 times 5 times 14, and that's actually 210 again. So the max is 252, and it's boxes. Alright, so for this one, slightly different because there isn't a restriction put on it, like the other two about saying it has to be upright or something like that. But to limit the number of different kind of calculations you'll have to do, it will normally feature something like this. So it might be a square bottom that reduces the number of possibilities, or it might have some kind of restriction, like this one for example, where it says it has to be stored a particular way. Alright, so that's the 3 container packing questions. Obviously there is more out there for you, you can have a go at those yourself.